Alright, so let's start with graphing inequalities. So we know the simple inequalities of x is greater than 4. And we're on a number line. And so when we graph x is greater than 4, put a circle at 4. Now, the circle is not going to be closed in because we don't have the or equal to sign with the greater than sign. So in any number that's greater than 4, you shade. So, if we had x is greater than or equal to 4, then what we would do is we would go ahead and fill in that circle. Because if it's or equal to, that means that it also could be 4. And so, graphing on a number line is very simple. You just find where the numbers that are greater than or the numbers that are less than, and you go ahead and shade that way. Now, on an XY graph, it's a little different because you have all kinds of numbers everywhere. So, when we want to graph an inequality, so say we want to graph the equation y is greater than or equal to 2x minus 1. Now, we would graph this as if this was just a equals to sign. So if this was just, say if this was y is greater than or equal, if y is equal to 2x minus 1, we'd start at negative 1 on the y-axis, because that's our y-intercept, and we'd go up 2 over 1. Now remember, you want to go up 2 and to the right 1. So you go up 2 to the right 1, and we can go ahead and just try to connect those dots. Now, so that's if it was an equal sign, we would go ahead and just graph it like a normal equation. So, and it's a solid line, just like if we had y is greater than negative 1, we would circle in or color in that circle on the number line. So if we had a solid circle, we'd also want to find the numbers that are greater than or equal to this line. So if you look at our y-intercept right here, where are the numbers that are bigger than that? And usually when it's greater than, it's above, and when it's less than, it's below. So if we figure that above is greater than, so we go ahead and shade everything above that line. So we shade everything above that line, and we're finished. But what you need to remember is that any point in the shaded area is a solution to this inequality. So if we pick, for instance, negative 2, 2 right here, that is the solution. But also is negative 2, 6. That's also a solution. Any point in the shaded area is a solution. So instead of looking for just a single point like we were when we were graphing just lines, we're looking for any of the shaded area is a solution. So let's try that again. So say we have an equation that we need, or an inequality that we need to graph. So say it's y is less than, 1/2 x plus 2. Now again, we could always say, well, this is just like an equal sign as far as graphing is concerned. So we start at 2 because that's our y-intercept. We go up 1 and to the right 2. Then we go up 1 to the right 2. Now the only thing with this line though is it's going to be dashed because we don't have that equal sign with it. So if it doesn't have the line, you don't complete the line. If it does have the line, it's a full line. Now again, you look at your symbol right here. It's less than. So if we were to look at our y-intercept right here, where are the values less than that y-intercept? And it's everything below that line. And so if you look at it that way, that obviously less than is below, greater than is above. you know pretty much where to shade at any time. You go ahead and graph it as if it's a line, and then go from there. So let's look at one more. And this time, actually, let's look at y is greater than or equal to 2x minus 1, and y is less than 1/2 x plus 2. Let's look at those two together. So we're going to start with this one first. We're going to be at -1, and you go up 2 to the right 1, and that's going to be a solid line again, just like when we graphed the first time because of this sign right here. Now anything greater than that is going to be above it. So we shade everything above the line. Now this is obviously a good trick into coloring, and can you stay inside the lines? So also let's look at then this one. Now we're graphing this on the same thing. It's like you're going to a buffet and you pick up this inequality, and you're going to pick up a little bit of this inequality. They're on your same plate, but they're just going to be two different things. So you start at 2, you go up 1 over 2, up 1 over 2. And remember, this is a dashed line because it doesn't have the or equal to. And less than that line is going to be anything below that line. Again, test your coloring skills. Now remember also, anything below that line includes every quadrant. It includes everything here, and everything here, and then everything below that. So remember, your main focus is going to be this line that you graphed, and below that line. Now, the part that is overlapping right here, so this is like if your food is touching, this part right here is your solution set to both of those inequalities. So that means that any point in this solution set, so like -1, -1, is a solution to this system of inequalities. It's a solution to both of them. So, for instance, any point in this yellow shaded area where they overlap is an answer to both of these inequalities. So basically, that's an ingredient in each one of our foods that we have, are those points. So if you think about the points as ingredients, if the ingredient is in both of the inequalities, then that means it's in the shaded area. If it's only in one, so say it's in our first one, it's in the blue shaded. If it's only in the second one, it's in our orange shaded. So let's look at another one. If we look at, now remember, graphing systems, you're going to have two lines. Now when we talked before, we wanted that one point where they intersect. Now what happened, though, sometimes they never intersected. And when that happens, that's called parallel and no solution. And we could have the same thing happen here too. But, so what do you notice about these two? If you look at the slopes of both of these, they're the same. That doesn't necessarily mean it's not no solution though anymore. So we start with the first one, it's 1, you go up 2 over 1, up 2 over 1. It's a dotted line because we don't have that or equal to sign right there. And we want greater than that line. So again, we're going to shade everything above that line. Make sure you're staying within the lines here. And then again we have this next one where we start at -1. Actually, we start at -1 here, so we're going to change that to a -1. Start at negative 1 there. Again, up 2 over 1, up 2 over 1, up 2 over 1. And this is a solid line. Now, what do you notice about those two lines, though? It's the same line. Now, but this is less than that line. So anything less than that line. Now, you got to ask yourself, where do these two intersect? Do they intersect? They're the same line, but with both sides shaded. But one is dotted and one is solid. So what that means is that these actually have no solution. Now, if one was solid and the other one was solid, then it would be a solution. So since that one kind of turned out a little weird, let's try something else. Let's try this. Oh, that needs to be a positive y because we don't like those negative y's. Greater than, let's say, 3/4 x minus 2. So again, we start just by graphing the line. We start at negative 1, go up 1 over 2, up 1 over 2. And it's a dashed line. And we want values greater than that line. So shade, 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 color, 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 color. Okay? Then we have our orange one. We start at negative 2. And it's 3 over 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay? So now, that's also dashed because we don't have the or equal to sign. And we want values greater than that line now. So we shade, 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 shade. So we're shading, and anywhere these two overlap is an answer. So say negative 1, 1, negative 5, 1, 1, 1. Anything that's in the shaded area is a solution to both equations. Now, if we were out here, like say, I don't know, 6, negative 4, now that's not a solution because it's not in the shaded area. So you go ahead and graph it as if it was a normal equation. So some steps to follow when you have a system of inequalities. And if you're following along, you need to have this in your toolbox. So, toolbox. The first step is to go ahead and actually what we're going to say is we're going to say it has to be in. So, get the equations in y equals mx plus b form, which of course is slope-intercept form. Number 2, you're going to go ahead and graph both equations and make sure that if it's greater than or less than, it's dashed. And if it's greater than or equal to or less than or equal to, it's solid. Now remember that's as if the open circle and closed circle on our number lines. Okay? Now when you graph both and then you shade according to the inequality inequality sign. So for instance, greater than usually is up or to the right. And less than is usually down and to the left. Now there's going to be some instances where you're going to have vertical and horizontal lines. And those you're going to have to look and see according to where the line is. Alright, if it's greater than, where are the values greater than that line? So where are the values that are bigger than that line? And where, or if the values were less than, where are the values less than that line? That's why it's usually up or to the right of a vertical line, or down and to the left of a vertical line. So we'll see an example of that in just a minute. So you go ahead and make sure that you have this down. If you need to, you can always pause it and get it down and then continue. So when I was talking about vertical and horizontal lines, let's look at an example of that. So if we had y is greater than 3 and x is greater than or equal to 4. Now remember, y is greater than 3, you go to 3 on the y-axis, and that is just a dashed line at y equals 3. Okay? And you want greater than that, so you're shading everything above that line. Because remember, where are the values greater than 3? Above it. Alright, so x is greater than or equal to 4. Now look at that, look at this right here. So for that one, what variable do you have? You have x. So you go to 4 on the x-axis right here, and that's going to be a solid vertical line, just like that. Now again, remember what I said about where to shade. If it's greater than a vertical line, you go to the right. Because where are the values greater than this 4 right here? To the right of it. 5, 6, 7, 8, 9, 10, a bazillion. All those are greater than 4. So remember, this shaded area right here is where all of your solutions are. And if this were to continue on forever and ever and ever, it would grow bigger and bigger. So anywhere that it overlaps, remember anything that's an ingredient in both, that is going to be an answer to both of those. So remember that. Now remember, if you have any questions about this, you can always ask. Replay this video if you need to. We're going to be going over it more in class on Monday, the 18th, I believe, or the 17th. And so if you have any questions, please feel free to ask me. Alright.